we were thinking about this earlier about like schooling and
Mm,
how math is taught. How is it different? Because you and I are childhood friends. How is it
yeah.
different than like how we were taught math, and what's something that you would like to see in the world of math education?
Well, I mean, I would say that like learning math has as much variability as like kind of any other subject could have. So like, I mean, I've had various professors that teach in different ways, and I mean, I think math definitely lends itself to like a lecture style type of learning.
Really?
Like, yeah, I mean, like it makes sense there, like especially in the more introductory courses, like well, the most frequent like intro course, most recent intro course that I took was modern algebra, and something like that. Algebra is about on an intro level is about group theory, groups and rings and fields, and it's very heavy with definitions. Like that is a very well established field. So when you're learning stuff like when you're learning that, it's very much like what defines a ring, what defines a field. It's memorization. It's I mean, it is difficult, but it is more like internalizing stuff that has already been established.
Okay.
So this is why like I found the lecture to be like the most useful. But I also have had professors who teach in like kind of like a flip style classroom. So I will watch a video or read a chapter or do some number of problems before class. And then when I get to class, I'm given a set of proofs to try and do, and I work them out with like my peers, and then try to learn in that way. And I think there are pros and cons. I like particularly the professor I'm thinking of. I love him very much, and he's taught me multiple classes at this point. And he always kind of does this different like flipped classroom style. But I also know that a lot of the other my like fellow math majors really don't like that style of teaching.
Hmm.
So some of it is up to preference, but I think there are reasons that both are good.
Wait, do math students read the
Um,
textbook?
It depends on the math student. I think that
this is such a
there's
Liam question. I hope
Yeah.
you know
Well, I
this.
don't know
This is a
many
very
engineers
Liam
that like
question.
spend their time reading the textbook. I mean, I don't
Well,
know. I feel
uh,
I
like it's
have,
not
and
necessary.
like
I
once,
have
a couple times.
a couple times.
I would say that it's so like person by person. It's one of those like I would think it'd be hard to generalize. It also depends on the class.
That's
Like
a perfect answer for Liam. That's just what he was wanting to hear.
I think there are definitely courses I've taken where like reading the textbook is like I haven't cracked the textbook once unless I'm looking for like the homework
Mm,
problems.
mm.
And then there are courses where it's like
Well, that's
I yeah. Or it's like I don't
that's why you buy the
understand.
textbooks.
Yeah, no, pretty much. But some of the courses it can be helpful to either try and read a chunk of the relevant chapter beforehand to like just like have the material at least kind of familiar before I go into class, or then go and read the chapter like after class to try and make sense of it if like whatever it was taught that was like
Mm.
very dense or hard to follow. But I will say that reading like just trying to read a math textbook is it's so hard to learn from just a textboot when it comes to
Well, they all
math.
try to sound so fancy, I feel like.
Yeah.
It's like
Yeah.
it's like
They
get over
yeah.
yourself. Like it's just speak normally.
Dude,
Hey.
do you like
It's all a formalization. There's a very specific way to write mathematical statements.
for math, like when you're like learning it, is it better for the kind of math that you're doing, like to visualize it, to give these like visual examples? Is that
Mm.
even possible? Because you're talking about graphs and like chords through polygons. Um, but is it easier to show someone stuff like that in a classroom setting and more like valuable for them as a student? Or is it better to give them the formal definition of like what you're doing? Because you mentioned chords, and all of us might know what that is, but people at home might not understand what a chord is. in
I can't
terms of
remember what
like
a chord
math.
is.
So, I mean, well, it's so just like very briefly, a chord
Yeah.
is going to be like basically a line segment that connects two vertices. And like it's kind of like if you think about like a chord in a circle, it's just like going to slice off like a little like kind of arc of that
So in that
circle.
case, it's not a vertice though, right? Because
Correct.
Well,
Yeah,
there's
but
aren't there
it's the same
infinite
it's
vertices?
like
terminology.
bounded by the shape.
Yeah, but
Okay.
that's kind of what I'm trying to get at is that like a chord is an internal edge.
So like the
Um,
diameter is a chord that goes through the midpoint of a circle.
yeah,
Got it.
Mm-mm.
but if I'm thinking about Finn's question, I mean I don't think that there is I don't think that you can do one without the other. Like
Okay.
I don't think that I would be able to really like understand any of the math that I've learned without doing examples. And that's honestly one of my critiques of like a flip style classroom of learning is that like it does tend to throw you into the more abstract end before getting your feet wet in examples. So like just like for instance when I was taking real analysis, like you do a lot of what are called epsilon delta style proofs, and these are epsilon and delta represent like little tiny movements left and right or up and down, just like infinitesimal differences that you're minimizing. And like proving that something is the derivative of something else involves one of these epsilon delta arguments. And there's a lot of like theory that then you can go into once you kind of know the structure of an epsilon delta proof. Like you can prove things about um I don't know, just like different like if you have like an equation of the form like y equals x to the n, you can prove like the derivative formula once you know this like epsilon delta style proof. um but like what's helpful is actually doing one where it's like, okay, you have y equals x cubed, and here and then the derivative would be like 3x squared, and then you use an epsilon delta argument to prove that, rather than jumping straight into the abstract where it's like you have an exponential, or not necessarily, that's not an exponential, but you have like a polynomial and you're looking for what the form of the derivative would be. I think the concrete example I need before I can do something like
Right.
a general proof.
But whoever invents that doesn't have a concrete example, or do they?
Oh,
Like
I think they definitely do. That's kind of what I was saying
that's like
earlier.
how
Like,
they reverse
yeah,
engineer it, I guess.
a little. I think there is a lot of reverse engineering that happens in the preliminary stages of math research. Like, because what I'm doing right now is I like what I did today was I drew like every single one of the 42 different ways to triangulate a heptagon, and I was thinking about like there's these things called dihedral groups, which represent the different ways to permute polygons that preserve the structure of the shape. And I was like, okay, what if I apply a rotation to a particular triangulation, and then like a flip, and that's a whole other that's like a very that's group theory, that's just abstract algebra. But I was drawing all of these shapes just like on a piece of paper, and I spent like an hour and a half doing that. Like I feel like I feel like there's like I have like an inkling that's like, okay, if I use the dihedral group, maybe I'll learn something about like which triangulations share a chord, because that does there is my broader research question, which I haven't actually talked about, but like is about shared chords in these different triangulations. And it's kind of just about like following instinct, making a bunch of pictures, and then being like, what are like where is the pattern here?